Okay, this is our trig review number 5. And here we're going to go back to the definitions of the trig functions. But we're not going to be looking at right triangles, nor will we be looking at unit circles, but rather any point xy in the plane. So consider the entire Cartesian plane, x-axis, y-axis, and any point with coordinates xy in the plane. And our task are to define the trig functions of the angle standard position theta with the initial side aligned with the positive x-axis and the terminal side going through our point xy. This is similar to our unit circle definition. This particular set of definitions, though, also has a very close connection to polar coordinates. And obviously we do polar coordinates at the very end of the course. And in fact, we have a test in just a couple of days. I'm recording this on Monday the 8th. Our polar test is on Wednesday the 10th. Okay, so here's our definitions. If we have the cosine of the angle theta, we are going to say x divided by r, and the sine of the angle theta is going to be y divided by r, and the tangent of angle theta is y divided by x. Note that these are similar to the unit circle definitions. But of course, on a unit circle, r is equal to 1, and here we're allowing r to be any value. And I suppose if we're talking radius of circle, we want r to be bigger than 0. Okay, so let's think about what this means algebraically. Here's our circle centered at the origin. This is x squared plus y squared. It's r squared. So r is the radius of the circle. R is the radius of the circle. You can think, if you want, r is going to be the square root of x squared plus y squared. And again, if we're talking circle geometry, r is always going to be positive. Radiuses are positive. When we get into the polar coordinates, we will allow, back up here, polar coordinates, we will allow r to be both plus or minus the square root of x squared plus y squared. But for now, let's assume r is positive. Okay, and using this definition, and given any point in the xy plane, we can immediately come up with these three trig functions of the angle theta. The reciprocal functions, secant, cosecant, and cotangent, are exactly the same as before. You would think that, let's just list them down here. The secant of theta will be the reciprocal of cosine, which is r over x. And the cosecant of theta is the reciprocal of the sine, which is r over y. And the reciprocal of the tangent, the cotangent, will simply be x over y. Again, note the restrictions we can never have for these denominator not equal to 0. And of course, the same thing for the tangent up here. Tangent x not equal to 0. Okay, a quick example. We'll sort of throw a little bit of light on this. Let's consider the xy point. Xy point, we'll do 3, 4. And a short sketch, 1, 2, 3, 1, 2, 3, 4. So here's our ordered pair, 3, 4. And here's our angle theta in standard position. Theta. Note, by the way, that theta doesn't necessarily have to be positive. We could consider the angle that starts, again, an initial side on the positive x-axis, but now rotating clockwise in the negative direction, as long as the terminal side goes through 3, 4. I'll call this one phi. Okay, both of these will have the same values for the trig function. So we can talk about the cosine of theta. That will be 3, the x-coordinate over r. Now, it's not too terribly hard to think. Let's see if we take away, let me take away some of my lines here. This is the point 3, 4. I say obviously. It should be clear that this point lies on a circle of radius 5. R is the square root of 3 squared plus 4 squared. R is the square root of 9 plus 16. R is the square root of 25, and R is 5. So cosine of theta is 3/5. Sine of theta is 4/5. And tangent of theta is going to be 4/3, y over x. Okay. So there's a point in the first quadrant. Let's pick one that's down in the third quadrant just to see what happens. Again, let me pull up a new screen here. Okay, so we have an xy point. We want it in the third quadrant. So let's make x be -2 and y be -12, just to pick an ordered pair. And a quick sketch. Okay, so -2 and -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Way down here, -12, -2. Here's our ordered pair. And we want the trig functions that correspond to this angle, whether it's positive or negative. I'll run it around positive this time. So there's theta. Okay, and the ordered pair, -2, -12. Because we know we're going to be dealing with r, it would sort of make sense early on to go ahead and calculate r as the square root of -2 squared plus -12 squared, which is the square root of 4 plus 144, which is the square root of 148. And just check to see whether or not that reduces. Let's see, 148. 274, so sure enough, 2 and 37. So you could write this as 2 square roots of 37 just to make it a little bit prettier. Okay, we have x, we have y, and we have r. So the cosine of theta is going to be x divided by r, which is 2 square roots of 37, which will reduce down to 1, -1 over the square root of 37. The sine of theta is the y-coordinate, -12, over 2 square roots of 37, which will reduce down to -6 over the square root of 37. And lastly, the tangent of theta is going to be y over x, -12 over -2, which is simply 6, +6. Okay. So this is our third definition. We had the right triangle definitions, we have the unit circle definitions, and now we have this set of definitions for cosine, sine, and tangent that deal with any point in the xy plane. Okay, let me stop this piece here. I want to pick up on polar coordinates though, and I'll do that on tape or video recording number 6.